Okay, this is my defensive instruction for learning target 8C, which is completing the square, in unit 8, which is solving quadratic equations by factoring and other methods. And also, it's one of the goals of unit 8 for students to be able to recognize when to apply which types of factoring methods as appropriate. So I introduced unit 8 with a Transformers movie clip. That was my hook in order to stimulate student interest and engagement and to promote emotional involvement with student learning. I used the Transformers video clip, and we talked about how cool it is that Transformers can be in both a robot shape as well as a vehicle shape. And we talked about the fact that there are advantages and disadvantages to both of those. So I had students complete a chart talking about the advantages and disadvantages of being a robot versus being a vehicle. And we talked about how with a Transformer, it's always the same Transformer. Bumblebee is always Bumblebee. It's just that sometimes Bumblebee is a vehicle and sometimes Bumblebee is a robot. We then related that to the concept of a quadratic equation being in standard form versus factored form. I had students do justify, think, pair, share, where they engage with a partner in determining a list of the benefits of being in standard form and factored form, which I then used, and I checked for understanding the next day with a quiz. And the quiz was all on prior knowledge, because even though I associated this with learning target 8A, this is really information that was garnered in unit 5. It's kind of like PK or prior knowledge that they need for unit 8 and for learning target 8A, which is understanding the difference between standard form and factored form. But we discussed all of this information previously in Unit 5, so I wanted to make sure and check their long-term memory to make sure that they still understood that. So, after that, I basically introduced completing the square with another IBE where I had shown some blocks on the Elmo, and I asked students first with just the green blocks, and I told them they were unit blocks, to complete the square, that these squares were incomplete, and they needed to determine how many blocks were needed to complete the square. From here, I asked students what it meant for something to be a perfect square number, and we discussed the dimensions and the area of the square that's created using the different blocks for the different numbers. The first one should have been 2 squared or 4, and the other one being 3 squared or 9. Then I moved that concept onto working with the algebra blocks. This is x squared plus 2x plus 1, but it's a perfect square because if I slide the green block into the gap there, then I would complete a perfect square that's x plus 1 on each side, and I could write that as a binomial squared, x plus 1, the quantity squared. Then I had students try some on their own. This was x squared plus 4x, and so I had the students create the block models themselves. Most of them, I had them draw it because I don't have enough block models, but some students actually required the physical manipulatives because some students, as Gardner would say, are kinesthetic learners and they need to actually touch things. So other students are visual, so they were okay drawing it. I had them try to deduce the number of blocks that were required to fill in the gap here. It's hard to kind of do while holding the video camera. But anyways, it requires 4 blocks. From there, we tried to generalize the pattern in the IBE. Some kids started to generalize it, and other kids were just really stuck. They were working with a partner, but they still couldn't figure it out. So I knew that was the time to introduce the deductive structured notes. I was worried about the cognitive load in the deductive structured notes, even though I used Fisher and Frey's model of I do, we do, they do, and you do, wherein students first watch the teacher model a procedure, then they do a problem with the teacher, then they do a problem with a partner or a group, and then they do the problems on their own. For the first step for the I do, I knew it would still be too much for students to be taking their own notes, so I had them highlight and mark up some already created notes for completing the square. You can see here that this student marked this section as PK because that's prior knowledge. Students already knew how to factor quadratics into binomial perfect squares here, and if they needed it in a verbal format, it explained here the purpose and rationale behind completing the square without really going into the algebra. And then here we talked about if a equals 1, what we would add and half the linear term squared on both sides to complete the square, and so on. And then I did these examples myself, and I was hoping to have students then move into the we do part, but we ran out of time. So we didn't complete highlighting these notes or finishing these notes, and I did still want to make sure that I checked for understanding and made sure that each student was individually accountable for what they learned that day. So you can see this is one student, her worksheet, in that she was actually able to draw the block model to determine the number that would make that that quadratic trinomial a perfect square there, and then to rewrite it in factored form as a binomial squared. Most of the students were able to at least draw the block model and determine the number to add at the end, but not all students were able to then go and rewrite it as binomial squared. So here's one. You can see student understands what they're doing, and however, you don't see them writing it as a binomial squared. So there were different levels of understanding that resulted from this lesson, and I knew I needed to bring the block models back. So the next day I tried to finish the lesson. I brought out a different set of notes to continue the lesson, and I thought this did a better job of explaining how to actually solve the equation once you did complete the square. So again, following the Fisher and Frey model, I do, we do, you guys do, and you do alone. I did this one myself, these examples here, and worked that out for them on the board for them to copy down into their deductive structured notes. I checked for understanding using thumbs up, thumbs down, and levels to determine when to move on to the we do section. I asked students thumbs up if you think you could try a few of these together as a class. About 90% of them said they could, so we moved on to the practice part. And there was another completely worked out example for them there. We did 1A and B and 2A and B together as a class and walked through the steps that way. And then students were expected to do C and 1C and 2C with a partner. They were almost all able to accomplish that. This is one student's worksheet, and then another student's worksheet, and then another student's worksheet. So I was getting really good feedback that they were being successful at this skill and that they were ready to move on to some active practice. So from here, what I did was I made Battleship with completing the square. And with the Battleship, it was 2 different sides of the Battleship. This is a game that they played with their partner. And the first side, it was just what would you add to complete the square. And then on the other side, it was actually solving it out. And I got some mixed results when students had to kind of do it on their own. I noticed about only maybe 60-70% of students were successful at that. So the next day, on their way in the door, I had a couple more problems, and I handed out some more blocks, and we went over it. And then later on in the unit, I brought it back with these popsicle sticks in a different mixed active practice, where you could see the color represents the skill, the learning target. So learning target 8C was green sticks. You could see complete the square, x squared minus 8x plus blank. Some of them, they just had to complete the square. Some kids used block models. Some kids were able to do the algebra. And on the back, it's the answer. So you can see the A and the Q for question and answer. So they would shape the popsicle stick box and pick one out and try to solve those on their own. And then for station day on ticket out the door, I gave another ticket out the door, and they had to do it based on which stations they went to. And this student was predominantly practicing factoring trinomials into the product of 2 binomials, and then she was also practicing completing the square. You can see here, knowing to add 16 to both sides, to simplify, and square root, and so on. But you could see 29, not a perfect square. I'm not sure what happened there, if she copied the problem wrong, so those were supposed to work out. But here's another one, another student, and apparently it was supposed to be, adding 36, it was supposed to be 49. So you can see I'm still getting mixed results, and the test is tomorrow. After the test, I'll reassess, and then maybe in about a week, we'll have stations again. I'll continue to have quick checks on this topic and integrate it into future lessons during whiteboard practice and things of this nature. So this is my learning target 8C, completing the square, and that's my defense.